Hello, in this video we're going to be taking a look at the properties of the graphs of sine, cosine and tangent. Now this is going to be really helpful when it comes to solving trig equations, which is what I'll be looking at in my next few videos. If this video is useful, then please do go over to my channel where I have loads of other videos, as well as my website, which I'll have linked in the video description. So let's start off by taking a look at the graph of y equals sine x. And you can see I have a section of this graph below, and it is only a section because this graph or this function will actually continue infinitely in both the positive and negative x directions. And so below this graph you can see I have a few key words, okay, and I'm going to talk about these and also some other things that are going to really help us when it comes to solving trig equations, which is what we're going to look at in the next few videos. So the first of these keywords is the period of the function. And this just tells us how often the graph or the function cycles or repeats. Okay, so to show you what I mean by this, let's look at the graph, and I'll start at x equals 0. So at x equals 0, it's obviously at 0. Then it goes up to 1 when x is 90. Then it comes down to 0 again when x is 180. Then it goes to negative 1 when x is 270. And then back to 0 again when x is 360. And you can see after this point, the graph just repeats itself again, and it's going to do this forever. Now this horizontal distance is called the period, so this distance here, which is 360 degrees, is called the period of the function. And so the function repeats every 360 degrees. So let's write that on there, 360. Now the minimum is hopefully more straightforward to see. That's the smallest or the minimum value the function outputs. And so if we take a look at this graph, where is it at its lowest point? Well, it's at this point here, where sine of x equals negative 1. And so the smallest value this function can take is negative 1. Now we can also talk about the maximum value, and this is the greatest value the function outputs, and having a look up here, that's at 1. So the function is going between negative 1 and 1. Now I have this final keyword, which is the amplitude of the function, and this is just the height of the wave from the center line to the peak or the trough. Basically from this center line that I could draw on here to the maximum or minimum value. And if I annotate this, hopefully you can see, well, we know the maximum is 1 from the minimum point, or the minimum is minus 1, so the distance from the center line to the max or min is just going to be 1. So the amplitude of sine of x is 1. Now there's a couple other properties I want to talk about that are going to be more useful when it comes to solving the equations, so I'm just going to get rid of some of these annotations. So say we were trying to solve an equation where sine of x equals a half. Okay, and I could zoom in on my graph and I can see the wave equals a half at this point here, which is actually when x equals 30 degrees. Now, a key property you want to know is that the graph is symmetrical about the point x equals 90 between 0 and 180 degrees. So I'll highlight that. So this is the section of the graph between 0 and 180 degrees. And at the point where x equals 90, which I'll mark on with a different color, so that's this point here. So there we go, that's 90 degrees. The graph is symmetrical, and hopefully you can kind of see that it's sort of mirrored around the point x equals 90. And so you can see if I was solving where sine of x equals a half, just by looking at this curve or this graph, I can see that actually there's another point where it equals a half, and it's this point over here. So how could I use this symmetry to help me find that other value? Well, I know from 0 I've gone 30 degrees to the right to get to this point, which means from this point over here at 180 degrees, because it's symmetrical, if I go back 30 degrees, that's going to take me to this other solution. So I do 180 minus 30, which is 150 degrees, and that gives me the other solution. Okay, so that's quite a key thing. So this symmetry is going to help us to find other solutions to our equations. Now there's another point of symmetry on this curve. I'll zoom in on it here. So between 180 and 360, so that's this point here, the graph has a line of symmetry at the point x equals 270 degrees, and I can mark that on like this. So here's the other line of symmetry, and that's at 270 degrees. So if you can kind of remember these lines of symmetry, it will help when it comes to solving our trig equations in the next video. Now if we go back to thinking about the period of the function, 360 degrees, this can actually help us with solving equations too. Because if I wanted to solve where sine of x equals a half, well, earlier we said it had two solutions, 30 degrees and 150 degrees. And you could type those into your calculator and see that that's true. But if the graph goes on infinitely in both directions, then there must be infinitely many points where the graph equals 0.5 or a half. And actually you can see that's true, because if I continue going across from point 5 like this, you can see there's another two solutions. There's one here and one here. And if I carried on, there'd be one over here and one here, and if I carried on going back, there'd be some over there too. And there would be infinitely many, okay? And we're going to talk about how we deal with this in the next video. But we can use the fact that the graph repeats every 360 degrees to find some other solutions. So for example, say I know there's a solution here at x equals 30. Well, if I add on 360 degrees to this, well, that's going to take me to 390 degrees. Well, that tells me that the other solution here is 390, because it's just repeated and it's at the exact same point again. And again, you can type that in your calculator and check that that's true. So let's now move on to the next graph, which is y equals cos of x, or cosine of x. And you can see it's slightly different. It's this time starting at the point y equals 1 when x is 0, but it still has this repeating pattern. So let's talk about that. So when x equals 0, it starts off at the point 1. Then as x increases, as it gets to 90, we're at the point 0. Then as we get to 180, it outputs negative 1. Then when we get to x equals 270, it's at 0. And then when we get to x equals 360, it's back at the point 1. And so you can see again, this is just repeating over and over again. And so the period of cos of x is the same as sine of x. It's also 360 degrees is the period. So let me annotate that on here. So there we go, 360 degrees. Now if we look at the maximum and minimum, it has the exact same property. It's got a maximum of 1 and a minimum of negative 1. Hopefully you can see that, so I'll write those on. And again, if we talk about the amplitude, well, what is the height of the wave from its center line to either its peak or trough? Well, you can see it's also 1, because the center line, if I go up to its maximum, that's a distance of 1. Or from the center line, if I go down to its minimum, that's also got a distance of 1. Okay. Now, let's talk about the symmetries again with this graph, because that's also going to help when it comes to solving trig equations. So I'm just going to get rid of the bits that I've already annotated. I'm going to zoom in on one period of the graph, like so. So that's going from 0 all the way up to 360. Now, the graph of cos of x has a line of symmetry at the point x equals 180 degrees. So I'll annotate that on here. So here it is. Here's my mirror line, or line of symmetry. There we go, so that's at 180 degrees. And so this is a line of symmetry from 0 to 360. And we can use this to help us in the same way as before. If I wanted to know where, say, cos of x equals 0.5, well, I could use my calculator that we'll look at in the next video, and that would tell me that x equals 60. So let me mark on that solution. So when x equals 60, cos of x equals 0.5. And so from 0, I've gone 60 degrees to the right. So if we use that information about the line of symmetry, I could say, well, okay, from 360 degrees, if I go backwards by 60 degrees, that's going to take me to the other point where it equals 0.5. And it does. And so we get there's another solution at x equals 300. And then we could use our knowledge of the period of the graph to find the other solutions that are either more positive or less positive than the ones we have. Let's now look at our final graph, which is y equals tan of x. And you can see it actually looks quite different from the other two trig graphs we've looked at. Now you can see it's got these dashed lines at these points here when x equals 90, when x equals 270, and another one here when x equals negative 90. Now these are called asymptotes, okay? And so at these points, the graph or the function is getting infinitely close to a point, but it's never reaching it. And if you're interested to see why that is, you can go back to the previous video and see where this graph comes from. But basically, as x approaches 90, okay, in the function, the graph is going to tend up towards positive infinity, okay, and it actually has no value for where x equals 90 degrees. It's undefined at that point, okay. Now, if we look between these asymptotes, you can see we've got this kind of interesting shape like this. And you can see this repeats infinitely, and so the period of tan of x is just this distance here between these 2 points, between the asymptotes. And in this case, that's 180 degrees, and so tan of x has a period of 180 degrees. Now, another interesting feature of tan of x is you can see it's constantly increasing, like it's constantly getting bigger as x increases within each period. Now, as a result of this, it's only going to have one solution within each period. So if I go back and look at cos, for example, you can see within this initial period there were two solutions where cos of x equals a half. And it was the same with sine of x. There were two solutions in the initial period where sine of x equaled a half. Well, with tan of x, we don't really need to worry about the two solutions as much, as there will only ever be one within each period. Okay, so that's something, again, we'll talk about in the next video. So hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and I'll also link my website in the video description where it may be a bit easier for you to go and navigate all of my different YouTube videos all in one place. Thanks for watching.